of you. Today's topic of lecture, I'm Rakhi Sharma, Assistant Professor in AKGEC, Ghaziabad. So today's lecture of electronic devices is dedicated to characteristics and modes of operation of BJT. These are the outlines that we cover during the entire lecture. First of all, we will cover the basic introduction of BJT, that is, what is bipolar junction transistor, its modes of operation, common emitter. Particularly in this lecture, we will discuss the common emitter configuration, the characteristics, the input-output characteristics of BJT in common emitter configuration. So starting with the basic introduction of BJT, what is bipolar junction transistor and what is its significance, particularly in case of electronic devices, we will discuss in this basic introductory part. So the basic of electronic system nowadays is a semiconductor device, and the most commonly device is the BJT, which is bipolar junction transistor, and it is an active device because its nature is particularly of providing the energy to the particular circuit. That's why its nature is considered as active device. So BJT mainly consists of three terminals, which are collector, base and emitter. It is basically of two types, which are NPN and PNP transistors. Modes of operation, depending on the biasing condition. Biasing condition means forward bias or reverse bias. So what is forward bias? Forward bias is that when the P side of a PN junction diode is connected to the positive terminal, we call it as forward bias condition. When P side is connected to the negative terminal, we call it as reverse bias. So this is the biasing condition which I have depicted as forward and the reverse bias of each of these junctions, which are operating in different modes of operation. So what are these? Basically in BJT, there are two junctions which are emitter based junction. The first one is the emitter based junction and the second one is the collector mode junction. So how the transistor is working, particularly in these two junctions, we will discuss in this. So particularly the three modes of operation in BJT are, the first one is cutoff mode, the second is active mode, and the third one is saturation mode. In this mode, particularly if we consider the first case, that is the saturation mode, in this the emitter based junction and the collector based junction, the both are in forward bias condition. That is, both the junctions, whether it is a emitter base or the collector base, they are in a forward bias condition. That is, P side is connected to the positive terminal of the battery. Second, next is the active mode. Active mode is particularly is that in which the emitter based junction is the forward bias and the collector based junction is reverse bias condition. And the last, which is the cutoff mode, in which both the junctions are in reverse bias condition. And what we observe in this is that particularly in case of saturation mode, when emitter based junction is forward bias and the collector based junction is reverse bias, the basic application of BJT is that it is working as a amplifier, particularly in the saturation mode. In active mode, it will work as a switch. When the emitter based junction is forward bias and the collector based junction is reverse bias, it is working as an open switch. If we reverse the polarity, it will work as a closed switch. In cutoff condition, it will not work, it will not give any results. So in this mode, BJT is not working at all. So the major applications of BJT are particularly in the saturation region and in active region. So these are the three modes of operation in BJT. The first one is saturation, the second one is the active, and the third is the cutoff region. This is all about the brief description, or we can say the differentiating part, differentiating the active region from the saturation region, then the saturation region from the cutoff region. So what we observe in this, in active region, as I depicted earlier also, the base emitter junction is forward bias and the collector base junction is reverse bias. So it is mainly used for the amplification purpose. Saturation region, in this the base emitter and the collector base junction both are in forward bias condition, and in this your BJT is particularly working as a switch. In cutoff region, both the junctions are in reverse bias condition. So in this, it is not working at all and it is not contributing in any of the applications. This is basically the basic diagram of BJT, in which we are seeing that there are three terminals. The first one is the base terminal, the second one is the emitter, and the last is the collector. This is all about the basic symbol, or we can say that the configuration of a transistor in NPN mode, and this is all about the emitter, the terminals of BJT, which are emitter, base, and collector. So, in this lecture, we are particularly discussing the common emitter configuration, or focusing on the common emitter configuration. But as we study or move on to the analysis of BJT, we will also cover the basically there are three configurations in BJT. The first one is common emitter, the second one is the common base, and the third one is the common collector. We discuss all these three configurations separately because each configuration has a significant role in any of the or major applications. But in this lecture, we are discussing only common emitter configuration and focusing on this common emitter configuration. So what is common emitter configuration? It is called common emitter configuration because in this your emitter terminal is grounded. Similarly, in case of common base, your base terminal is grounded, and in common collector, your collector terminal is grounded. So this is the point of differentiation which we use to categorize these three configurations. That is how we are able to differentiate between the three configurations. This is the base. That is, if it is in common emitter configuration, then your emitter terminal is grounded. If it is in common base configuration, then your base terminal is grounded. And if it is in common collector, then your collector terminal is grounded. So this is about the basic introduction of common emitter configuration. It is called common emitter configuration since the emitter is common or reference to both the input and the output terminals, or in other words, as I said earlier also, that is your emitter terminal is grounded in case of common emitter configuration. Almost all the amplifier design are designed using this configuration due to the high gain, current gain, voltage gain, and finally your power gain. So this is the most widely used configuration in all the major applications because it offers high gain in terms of current gain, voltage gain, and finally your power gain. So the next point, two set of characteristics which are very necessary to describe the behavior of this common emitter configuration are: the first is the input, that is your base terminal, and the output is basically your collector terminal, and the third terminal, which is the emitter, is grounded with respect to the emitter and the base terminals. This is basically the basic diagram of the common emitter configuration, in which what we are observing is that this is the configuration in case of particularly for NPN transistor, and this is the configuration for particularly your PNP transistor. So what we are observing in this case for your common emitter configuration, your emitter terminal is grounded. Similarly, whether it is PNP or NPN transistor, if it is in common emitter configuration, then your emitter terminal is grounded. So this is your particularly your input side, this is your output side. We are getting the output particularly from the collector. Particularly from the collector. This is your particularly your input side, and this is your output side. So if we have the clear picture of a circuit in our mind, we are able to justify or clearly define the characteristics of BJT in terms of input-output characteristics. So to draw or to analyze the input-output characteristic, it is very important to first of all to analyze its basic circuit. That is basic circuit in common emitter configuration. So as I said earlier also, BJT, first of all, it is a bipolar junction transistor. Why we are saying it is a bipolar? Because the current flow in this device is mainly because of mainly because of the two charge carrier, which are the electrons and the holes. So it is bipolar in nature. The second important point, it is an active device. And the third one, it is a current control device. Why we are saying this current control device? Because it helps in the regulation of current and also help in amplification of a current. So the common current equation, as we are saying in this is the current equation in case of BJT, which will remain same if we change the configuration also. In this, we are particularly talking about the common emitter configuration. But if we change the configuration from common base or common collector, this equation will remain the same. This is the universal equation, which is the current equation for the BJT, and it is same for all the three configuration. That is why we are saying that it is the universal current equation in case of BJT. So what we are observing in this circuit diagram is that it is a NPN transistor. This is your base terminal, this is emitter, and this is collector. So this is the base voltage, that is VBB. This is the collector voltage, supply voltage, or output voltage, also considered as the output voltage, VCC. That is, we are getting the output in terms of the collector current. So this is the basic circuit diagram analysis of BJT in common emitter mode, in which we have realized or derived this equation, which is called the current equation for the BJT in common emitter configuration. So now to analyze the characteristics, we are discussing the characteristic part also of this BJT in common emitter configuration. To draw the characteristics, it is very essential to keep in mind the circuit diagram of this NPN transistor or PNP transistor in common emitter configuration. This is the input characteristics. As I said earlier, particularly this is the input part. If it is the input part, VBE is the input voltage. That is the voltage across your base and emitter terminal. And this is the VCB output. That is the output voltage across this collector junction. And the current that we are getting, that is IC, which is the output collector current. So this is basically depicting your input characteristics, and it is basically between your VBE, that is the input voltage, base emitter voltage, and your IB, that is the input current which is flowing through the base junction, that is IB. So what is input characteristics? Input characteristics is basically VBE versus IB. This is VBE versus IB, taking your VCE as constant. What is VCE? That is the collector output voltage that is we are getting at the emitter collector junction. So the keeping VCE as constant, we are obtaining the input characteristics of BJT in common emitter configuration. So what we are observing in this, particularly we are taking that is IB in microampere, which is the base current. Its value is very small, that's why we are taking it in microamperes. And VBE is more than 0.7 electron volt for the silicon, and is 0.3 electron volt for the germanium, which we also call that as the knee voltage or the cut-in voltage for the silicon and for the germanium. Before this value of IB, it is very small and no current is flowing. Base emitter junction is forward bias. When it is forward bias, this will lead to the increase in VCE, which will reduce the value of IB for different values. So what we are observing is that as we are increasing the value of VBE, the value of the base current is decreasing. Or increasing the value of VC or taking the VC as constant, what pattern we are observing? The IB is decreasing. So this is all about the description of the input characteristics of BJT in common emitter configuration. So one of the most important point in this is that your cut-in voltage, knee voltage for silicon and germanium, its value is very important, and we have to remember for the analysis of part of or solving the numericals. This is VBE is particularly 0.7 volt for the silicon and it is 0.3 volt for the germanium. So this is the point which is taken into account or has to be remembered. That is one of the most important point for the analysis of input characteristics of BJT in common emitter configuration. Now, coming on to the output characteristics of BJT. If we consider the output characteristics of BJT, what we are observing is that this is the characteristics between your VCE versus your IC. That is the output part. In the circuit analysis, what we have observed, your input and the output part. So output characteristics are basically obtained between your output voltage, that is VCE, and your current IC, taking your current IB, that is base current, as constant, we will obtain your output characteristics. So what we are observing is that we are getting three modes of operation. The modes of operation that we have discussed prior also, particularly this is the cutoff mode in which it is not giving any of the major application, that is, it is not working at all, because in this both the junctions are in reverse bias condition. In active region, particularly, it is working as a switch. In saturation region, it is working as a amplifier. So this is all about the applications of the three modes of operation, and these modes of operation we are getting in output characteristics in common emitter configuration. So discussing the major thing are that for a small VCE, as VCE is less than V saturation, IC increase linearly with increasing of VCE, and what we will observe is that it almost get constant as we increase the value, or we can say as the value is decreasing, we are obtaining particularly the flat curve as we are moving downwards. So this is all about the description of the output characteristics of BJT, which is plotted between your VCE and IC, taking IB as constant. So this is all about the description of, or we can say that the analysis of the characteristics of BJT in common emitter configuration. So summarizing all the things what I discussed or in this entire lecture is that first of all I have discussed the introductory part of BJT. What is BJT? So BJT is a bipolar junction transistor. Why bipolar? Because in this the current is flowing mainly because of the two charge carriers, which are both, the contribution is दोनों का contribution होगा, which are the electrons and the holes. Next, it is a current control device in which the current equation as we derived earlier also is given by IE is equals to IB plus IC, which is the universal current equation for BJT and will remain the same even if we change the configuration of BJT. So if whether we are working in common emitter configuration, we are working for common base, common collector, this equation will remain the same. So it is a current control device, and its main purpose or main application of BJT is that it is working as an amplifier, it is working as a switch. So as an amplifier means it helps in enhancing the signal strength. Its major role is in enhancing the or modulating the signal strength. So it is working as an amplifier. So then we discuss the basic symbol or the diagram of BJT. It is basically of two types, that is NPN and PNP transistor. It consists of three terminals, which are emitter, base and collector. It has two junctions. The first one is the emitter base junction and the second one is your collector base junction. Based on these junctions and its polarity, it has three modes of operation, which are particularly the active mode, saturation mode and cutoff mode, in which we change the biasing condition and operate in that particular mode, and the resultant will be the required application. So there are three modes of operation of BJT. Next, we have in this lecture we have discussed the common emitter configuration. Why common emitter? Because it is widely used in all the applications. Why in all the applications? Because it is offering high gain in terms of voltage gain, current gain and power gain. So we have discussed the common emitter configuration, its basic circuit diagram and its input output characteristics, how we plot the input output characteristics, and various parameters that are used for the analysis of BJT that we will discuss in the next lecture. That will be the part of the analytic analysis of BJT, in which we will discuss the derivation of your input resistance, output resistance and your current gain, voltage gain for the different configurations. So I think the main carry away point or the take up point in this lecture is to particularly focus or analyze the input output characteristics. And input characteristics, it is essential to remember that the knee voltage or the cut-in voltage is particularly 0.7 volt for the silicon and it is 0.3 volt for the germanium. Output characteristics, moving on to the output characteristics, we will see the different modes of operation, that is how it is operating in different modes and its significance and how it is operating in different modes and applying to different regions. So this is all about the description of the output characteristics, and in the next lecture basically I will cover the your next configurations, which are common base configuration and common collector configurations, and the analytical part in which we will derive the parameters of BJT, which are input resistance, output resistance, your power gain, voltage gain and finally your current gain, because current gain is also different for all the three configurations, which are particularly for common emitter it is alpha, for common base it is beta, for common collector it is gamma. So all these parts I will discuss in the next lecture. That will be the analysis part of BJT that will be, I will cover in the next lecture. So that's all about in the today's lecture. Thank you so much.